Hello everyone. So welcome to the AnalogX. Today we will solve this numerical problem. So this is very important question. This question was asked in written examinations and interview also. So this is very practical question. So please solve this question. So let's read this. They have given assume all the devices in figure have P overdrive of 200 millivolt and intrinsic gain is 50 and reference current is 200 microampere and they have given case 1 the random mismatch variation of M2's Vth is 10 millivolt larger than of all other transistor. Okay, so in case 1 the Vth of M2 is 10 millivolt larger than the other all transistor. Okay, and in case 2 the random mismatch variation of M1 Vth is 10 millivolt larger than of all other transistor. Okay, so in case 2 M1 Vth is 10 millivolt larger than the other all transistors. Okay, so they have asked percentage error in I out due to these variations. Okay, so ideally this should be equal to the 200 microampere, but due to Vth mismatch there will be some error in output current, so they are asking percentage error. Okay, so let's solve this question. First we will solve the second case and then we will move to the first case. Okay, so suppose there are two transistors here. So if voltage is VGS and VTH, okay, and this have voltage of VGS and this one have 10 millivolt of extra VTH. Okay, so what will the V overdrive here? V overdrive will be VGS minus VTH, and what will be here? V overdrive will be VGS minus VTH plus 10. Okay, so I can also write this one as VGS minus 10 millivolt plus Vth. Okay, so here we can see that the mismatch in Vth can be grouped into the VGS. Okay, so either I can say that this transistor have higher 10 millivolt Vth than this transistor, or in second way I can say that this transistor have 10 millivolt lower than this transistor. Okay, so we can understand both way. So similarly we will deal with these situations. So in case 2 they have given this transistor M1 and this have Vth of 10 millivolt extra. Okay, Vth plus 10 millivolt. So this 10 millivolt will be appeared as here 10 millivolt of VGS. Okay, so due to this 10 millivolt, what will be the small signal current? This is Vth mismatch, random mismatch we will treat as small signal analysis. Okay, so this will create a current of Gm into 10 millivolt of current. Okay, so this is the mismatch current. So let's calculate Gm value. So they have given Gm R naught equal to 50 and I reference is 200 microampere. V overdrive is 200 millivolt. Okay, so you know that Gm equal to 2ID by V overdrive. So 2 into 200 micro divided by 200 millivolt. Okay, so this will come as 200 cancel out, millivolt to micro, so that will be millisiemens. Okay, so that will be 2 millisiemens. Now what will be the delta I? This delta I will be Gm into delta VGS, that will be 2 millisiemens into 10 millivolt, so that will be 20 microampere. So now what will be the percentage error? Percentage error will be delta I by I into 100, so that will be 200 microampere divided by 200 microampere. This is 20 into 100. Okay, so that is 10%. Okay, so this error is 10%. So due to mismatch in this transistor, Vth of this transistor, there will be some 10% of error in this output current. Okay, now let's solve the second case. In second case, here there will be 10 millivolt mismatch. Okay, so now let's see the effect of this mismatch on this current. Okay, so in case 1, this one is M2 and this one is M1. Okay, and this one is ID. So this one is 10 millivolt plus minus 10 millivolt of error. So now here we can see that this is a source degenerated circuit. Okay, so here also the mismatch current will be delta I will be Gm into delta V, where Gm is source degenerated circuit. What will be the Rs here? Rs, if we look from drain, so that will be R not only. What will the effective Gm? So that will be Gm divided by 1 plus Gm into R naught. Okay, Rs is R naught, and this one is delta VGS is 10 millivolt. So ignoring this one, okay, so that Gm will cancel out, and that will come as 1 by R naught into 10 millivolt. What will be the percentage error? The percentage error will be delta I by I into 100. So delta I 10 millivolt divided by R naught, and this one is I. Okay, so into 100 percentage. So let's put the value. What will be the R naught? R naught will be Gm R naught divided by Gm. Okay, so this given as 50. So this value are given, we will just put. So R naught is Gm R naught 50 and Gm is 2 millisiemens into 200 microampere of ID into 100. So when you will calculate, you will get 0.2% of error. Okay, so due to mismatch in Vth in this transistor, there is a percentage error of 10%, and due to Vth error of in M2, there is percentage error of 0.2%. Okay, so because of this source degeneration, there is a high output resistance if you look from M2. So that's because of there is less change in I2, I out because of M2 Vth. So solve this question and let me know if there is any doubt or you see any wrong solutions. Okay, and you can also solve by Vth mismatch. So you can solve like there is some this 10 millivolt of M2. This will come as source follower here. Okay, so that will come 10 millivolt, and then again M1 and M1A there is Vth mismatch. So from that also you can solve this problem. From that approach you will also get the same answer. Okay, thank you, bye.